We are students from the Governor School at Innovation Park conducting research on biofilm eradication using proteolytic enzymes. Biofilms offer protective shelter for bacteria to thrive in their environments, causing persistent infections that respond inconsistently to antimicrobial treatments. S. epidermidis is the leading cause of bloodstream infections due to its biofilm, costing U.S. hospitals about $2 billion per year. Our research aims to suggest novel, effective methods for biofilm control, thus ensuring the safety of millions across the globe. The question we asked was, what is the effect of proteolytic enzyme exposure on the adherence and degradation of S. epidermidis' biofilm on hydrophilic and hydrophobic surfaces? We hypothesized that if S. epidermidis was exposed to proteolytic enzymes, then its amount of biofilm degradation will increase and its biofilms will adhere more to hydrophilic surfaces.
12 hydrophilic stainless steel and hydrophobic carnauba wax pieces were placed into 24 separate tubes. Then S. epidermidis was rehydrated and incubated for 48 hours. Afterwards, 20 milliliters of luria broth and 200 microliters of bacteria was placed into each tube and incubated for 48 hours. As shown in the diagram below, 250 microliters of amylase, alkylase, and 10% bleach were added into respective tubes with 3 replicates for each substance on both surfaces. The tubes were then vortexed for 30 seconds, centrifuged for 5 minutes, and vortexed again. Biofilm was then pipetted from the tubes into a 96-well plate. 125 microliters of a 0.1% crystal violet solution was added into each well and stained for 48 hours. The plate was then rinsed with distilled water and placed under the Synergy LX for light absorbance measurements. The graph represents light absorbance of bacterial biofilm on hydrophilic and hydrophobic surfaces. A low light absorbance value indicates effective biofilm removal as more light was able to shine through. Results proved initial hypothesis correct. S. epidermidis adhered more to hydrophilic stainless steel than hydrophobic wax. Alkylase degraded 10.2% more biofilm in the hydrophilic group and 60% more in the hydrophobic group, compared to the negative control. A two-tailed t-test was conducted between the control and experimental groups, finding the results to be not statistically significant. However, results show enzymes have the ability to effectively degrade biofilm, especially alkylase with the lowest p-value of 0.07.
We plan to reconduct and consolidate experiment results, use the papain enzyme and test its effectiveness compared to amylase and alkylase, and test whether a cocktail of these enzymes enhance the degradation effect on the biofilm.